Welcome to this session. This session we discuss about orthogonal transformation of quadratic forms. In the previous session, we discussed about the linear transformation. So we want to see the difference between linear transformation of a quadratic form and orthogonal transformation of a given quadratic form. So if you have a real symmetric matrix A, real symmetric matrix, A can be reduced to a diagonal form M transpose A M is given by D. So let's call this diagonal transformation, let's call it question 1. Let's call this one 1. That any real symmetric matrix can always be transformed into a diagonal matrix. So where M is the normalized orthogonal model matrix. You remember the definition of model matrix from diagonalization process. And D is its spectral matrix. If these terms are not making sense to you, please check the previous video on diagonalization. Now, let the orthogonal transformation be x my. Remember, in the case of linear transformation, we are saying x equals to py. For here, we are using m, which is normalized orthogonal model matrix. Then we know that quadratic form is given by x prime a x. This is by definition. So which means we can replace this one by, where there's x, we put my, and then we have a matrix, and x is given by my. This is just the definition of x from this transformation. So the transpose of this matrix will be y transpose m transpose a m y. Now, after simplifying this, you see that in the middle here, we have M transpose A M. And from definition, M transpose A M is the definition of the diagonal matrix D. So we can write this one as Y transpose and then diagonal matrix whose elements are just the eigenvalues and then you multiply by matrix Y of the vector Y. So this can be written as, so Y1, Y2, up to Yn times lambda 1, 0, 0, 0, 0, lambda 2, 0, 0, 0, lambda 3, 0, 0, 0, up to lambda n, and then you multiply by the matrix Y1, Y2, Y3, up to Yn. It should be clear that if, so remember this is the quadratic form Q, if you multiply these three matrices, you will have lambda 1, Y1 squared, plus lambda 2, Y2 squared, plus lambda 3, Y3 squared, up to plus lambda n, Yn squared, which is called canonical form. So that's what we have. So in summary, we can say, now we have seen that quadratic form given by x transpose A x can be reduced to the sum of squares. You can see it here from the result here, by the transformation x equals to p I, where p is the normalized model matrix of A. So this would be P, Py. So that's what we have. The next session will give some definitions, how to classify a quadratic form. Thank you.